Okay, so now we're going to put our sine waves all together and try and take that information we know now and apply it to real world situations, because that's what the Common Core is all about. So we're going to start off with something you should be very familiar with, tides. We have high tide and low tide. All right, so it says here, tides in a particular bay can be modeled with an equation on the form D equals A cosine BT plus C. Okay, so actually I'm going to take my highlighter here and I'm going to highlight that because that's important. They're telling me to model it on a cosine wave. T represents the number of hours since high tide, and D represents the depth of water in the bay. The maximum depth is 36 feet, and the minimum depth is 22 feet, and high tide is hit every 12 hours. All right, so to get our mind around this, let's get some things straight in our head. It asked for a cosine wave. So I want to think about a cosine wave's basic shape. Well, cosine's basic shape is you start high, go low, and end high. And when we're talking about tides, that makes sense. High tide, low tide, high tide. And that's one complete cycle from beginning to end. Cosine waves have a period, so we're looking for how long it takes to make a full cycle. Well, if we come up here, it says high tide is hit every 12 hours. So that means it took 12 hours to go from high tide to low tide to high tide. Cosine waves have a high and low, and what are those high and lows? Well, once again, at a highest point, we have a depth of 36 feet, and at a lowest point, we have a depth of 22 feet. We're going to put all that information together and make an equation of a cosine wave. So down here, I have my axes set up, and we're going to rewrite depth equals amplitude cosine. I'm going to factor out the frequency plus C. All right, so the amplitude seems to be that everybody understands the amplitude very well. It's high minus low, take the absolute value, and divide by 2. So here we are using this piece of information. Well, 36 minus 12 is 14. 36 minus 22 is 14 divided by 2. We just figured out the amplitude is 7. All right, they told us it was a cosine wave. And now we want to figure out this B. Well, remember yesterday we had a little formula? Period equals 2 pi divided by the frequency. So now we're going to use this second piece of information right here. How long did it take to make a full cycle? That was a period. Just like we say it takes 43 minutes to make a period at Pearson, it takes 12 hours to make a period from high to low. I simply put that into my formula, cross multiply, divide out, and there's our frequency. It's a weird number. It's pi over 6. It's not a nice number like yesterday when we were practicing graphing sine and cosine waves, and we gave you a nice frequency of 2, so its period was pi. So this period is pi over 6. And then our final, may run out of room here to do it, is how far was the cosine wave shifted from mama? Well, we know that before we did any shifting, once we found this amplitude of 7, that its normal range would have been from -7 to 7. But somehow that got shifted because this new tide says we have a low of 22 and a high of 36. So what number did I add to these 7 and -7 to get to 36? Well, you can see that we added 29. -7 plus 29 gets you 22. 7 plus 29 gets you 36. So there. So if I were to write the equation now, this is what I would get. The depth in this bay is the equation 7 is the amplitude. We already know it's a cosine wave. We figured out its frequency was pi/6 based on time, and that it was shifted by 29. So if we drew a rough picture of that, 36 is my high, 22 is my low, and every 12 hours, this is going to happen. So tankers cannot be in the bay when the depth of the water is less than or equal to 25 feet. Set up an inequality and solve it graphically to determine all the points in the time interval from 0 to 24, where tankers cannot be in the bay around all answers to near 10th of an hour. Whoa, what are they asking there? All right, so I'm going to clean this up over here because I need some more room to write. And let's get some things straight here. Tanker cannot be in the bay when it's less than or equal to 25 feet. So here's 36, here's 22. So 25 seems to be right about there. So that's all I did. I wrote here, this is the line, roughly, y equals 25. Set up an inequality. Okay, so I have my equation of my cosine wave. So when the cosine wave is less than or equal to 25, this is the way I'm going to look at it, I'm in trouble. My tanker will run aground. Solve it graphically to determine all points in the time interval from 0 to 24 where the tankers cannot be in the bay. All right, so that brings us a little problem here. Our graph right here only goes up to 12 hours. If we add on another 24 hours, I'm going to have to kind of shove it in here. There's 24 hours. We realize, here we go. We realize that there is a certain time frame here when this tanker can't be in here. It's this time frame in here, and it's this time frame in here. All right, so now, how do I solve this? Well, just that, I solve it. All right, so 7 cosine pi/6 t plus 29, when is that less than or equal to 25? All right, I'm going to minus 29. That's -4. I'm going to divide by 7. And now we've got to bring something back from geometry. I've got to get rid of this cosine. How do I get rid of cosine? I inverse cosine? I do its inverse operation. So grab my calculator. First thing I'm going to do, so the first thing I'm going to do is make sure I'm in radians. I'm not. Why am I in radians? Because I have this pi right here. All right. So I inverse cosine -4 divided by 7. And I get this answer of 2.1, we'll say it's 2.18. So pi over 6 times t equals 2.18. Remember, this and this just crossed off. I still have to find t here, which means I'll do the inverse operation over here. I'll multiply by 6 over pi. These will cross off, and I'm going to be left with finally what t equals. Okay, when I go back to the calculator, I have 2.18 times 6 divided by pi, and I get 4.16. So t equals 4.16. All right, to the nearest tenth of an hour. So t equals 4.2. Come back up here. And what does 4.2 mean? Well, if my page would stop moving. And what does 4.2 mean? Well, if my page would stop moving. That means that this point right here represents 4. All right, so hang on with me. It's really not that hard, but you're just going to have to hang on here. So if I drew a line right here, draw a dotted line down, that means that this was the x value of 4.2. We obviously have to find out what this x value is right here. Well, we know that this point represents 12 hours. So the distance of low tide here, that took 4.2 hours. So guess what? The mirror image of that is right here. So this is also 4.2 hours. So I can find this number by simply saying, well, my height here is 12, but if this green was 4.2 hours, then this is also 4.2 hours. So I'm minus 4.2, I get 8, I get 7.8. So the first time frame says that that this tanker can't be in the bay between these hours after the first high tide. Okay, so then when we go back up here, we have the same again, because now we have to look at after the second high tide hits. So once again, this is still the mirror image. That is 4.2 hours after the second high tide. Well, then what I'm going to do there is I'm going to say that's 12 hours plus we found out that was 4.2. So 12 plus 4.2 tells me that is 16.2. And then this is the mirror image and this up here was 24 hours. So this next time frame is 24 minus 4.2. Get the right pen up here. So 24 minus 4.2 is 19.8. So the next time frame that the tanker can't be in the bay is 16.2 hours after that first high tide, up to 19 point, what did I just say? 8 hours after the high tide. No, I know that's a lot to handle, and that's why we're taking our time at this point, because these are the type of questions that the regents are going to put. All right, so tomorrow in class, we're going to work this one through, and maybe even this one. So make sure you took some good notes and be ready to have the magic picker pick people to come to the board. Grady, Grady, Grady.